All right, y'all. Today we are going to look at adding and subtracting rational expressions without already being given a common denominator. Okay, so hopefully last lesson you felt really comfortable with. We were already given the common denominator, just added right across the top. Okay, so we have this kind of one extra step of figuring out what our common denominator is, and then we'll move forward from there. Okay, so we're just going to go straight into the examples. So the first one says 15 over 2x minus 16 over 3x. Okay, so what I have to do first is I have to first figure out what multiple these two things have in common. Okay, so 2 and 3 obviously are not the same number. Okay, what multiple of 2 and multiple of 3 would be the same? So I'm looking for the least common multiple. So think of factors of 2, 2, 4, 6, 8, blah, blah, blah. Factors of 3, 3, 6, 9, 12, blah, blah, blah. What is the smallest number that they have in common? 6. So our least common multiple is 6. Okay, so that's going to give me the constant or the number. And now I'm going to look at my variables. These are the same variables, so I don't have to multiply it by anything. Like if one of them had x squared and the other only had 1x, then I would have to deal with that. But they're both going to have a 6 in the front, and they're both going to have an x. Okay, so what we're going to do now is we're going to take this fraction, and we are going to multiply it by something. Now we can't change its value, so when we multiply it by something, we're going to multiply it by a value that's equal to 1. So we're going to multiply this by something that's going to change the 2x into a 6x. So 2 times what makes 6? 3, right? So 3 times 2x is going to make 6x. So we're going to have a 3 on the top and a 3 on the bottom. Okay, so when I do that, all we're doing is this. 3 times 15, there's like a time sign right here. 3 times 15 is 45. And 3 times 2x gives us our denominator of 6x. Okay, then we do the same thing to our other fraction. Okay, so what do I have to multiply 3x times to make 6x? 3 times 2 makes 6. So I'm going to multiply the numerator and denominator by 2. 2 over 2 is the same as 1. So 16 times 2 makes 32, and 3x times 2 gives us that denominator of 6x. Okay, and the only thing I have to do now is go back and put in my subtraction sign. So the numerator now is going to be 45 minus 32. 45 minus 32 is 13. My brain is fried, y'all. Over 6x. And once I simplify that, then I want to look to see if I can reduce this or simplify it any further. 13 and 6 don't have anything in common, just my x value. Okay, so that's it. So again, we're looking for our common denominator. Once we find that common denominator, we're going to multiply both fractions by something to make that common denominator, and then we solve just like we did the other day. Okay, all right, so the second one is going to say 4a over a squared minus 7 over 8a. Okay. All right, so first things first, let's look at the number. This one has an 8. This one has no number. So what number is there? A 1. Okay, so what is a common multiple of 1 and 8? It's going to be 8. Okay, so if one number doesn't have a number, you got to multiply by whatever's on the other one, right? Okay, so I'm going to have an 8, and then I'm probably going to have some a's. Okay, how many a's will I need to make sure I deal with all the a's that are here? Okay, could I just have one a? Could it just be 8a? Would that be enough to cover this? Please say no. Nope, because this one has a squared, so that's 2 a's. So I'm going to need to make sure that I have a squared to cover all of these in this denominator. Okay, so when you're looking at your variables, you're always going to go with whatever's the bigger one. Okay, so 8a squared is going to be my common denominator. I can change this a squared into an 8a squared. by multiplying the top and bottom of this fraction by what? In order to become 8a squared, I need an 8 to go with this a squared, right? So I'm going to multiply top and bottom by 8. The bottom's already done. It's over there. So the top is going to be 8 times 4a. 8 times 4 is 32a. Okay. Then we look at the second fraction. What am I going to do to this fraction to make it 8a squared in the denominator? I already have 8a, so I don't need a number. I already have 1a, so I really only need one more a. So a times a is going to give me that a squared. So we're going to multiply top and bottom by a. So we're going to have minus 7a. 32a minus 7a makes 25a. Is that right? 2, huh? Yeah. Oh. I have the answers right here on my paper. I'm pretending like I don't know what to do. I know. All right, so 25 only divides by 5, which 8 doesn't divide by 5. So that fraction's not going to simplify. Can I simplify these a values right here? Yep. So I've got 2 minus 1, which is going to leave me with just a. It's going to go down here on the bottom where there were more a's to start with. So a over a squared becomes a. Okay. Again, we're kind of building on all of those simplifying rules that we dealt with last week and the week before. So go back and review those if you need to. All right, number 3, k squared plus 16 over 5k minus 10 minus 4 over k minus 2. These are all subtraction problems. That's okay. We'll get to addition. Okay, so this is our problem. All right, step 1 is to figure out a common denominator. Okay, if you cannot automatically see the same terms here, we're going to need to simplify this. Like this 5k minus 10, those 5 and 10 can both be divided by 5. So I'm going to reduce or simplify this. Okay, so here's what I'm going to do. I'm going to bring the k squared plus 16 down. I'm not going to do anything with that. Down here in the denominator, I'm going to divide out a factor of 5. So 5k divided by 5 leaves k, minus 10 divided by 5 is 2. So all I did was I changed 5k minus 10 to 5 parenthesis k minus 2. And then I look at this fraction over here. Is this denominator already simplified? Yes. So I'm just going to leave that alone. Okay. Now I'm going to look at these two denominators to see what factors they have in common. Okay. This one has a 5. So I'm going to need this one to become a 5. So I will have 5 in my denominator for my answer. And then this has a k minus 2. And this has k minus 2. So we're going to need a k minus 2 in our denominator. Okay? That is our common denominator, 5 quantity k minus 2. Okay? So what you should notice here in this first fraction is we don't have to change anything, right? This denominator is the same as our common denominator. So all of this stuff up here in the numerator is just going to come over into our answer or into our work. We haven't done anything with that yet. And then here, this second fraction, it has k minus 2 as our denominator. So what do we need to multiply that by on top and bottom? 5, yeah. So this gives us our denominator. So up here on the top, it's going to be minus 4 times 5, which is 20. Okay. All right, so now we can simplify what we have. So we got a k squared up at the top. I only have one k squared. And then I have this plus 16 minus 20. Plus 16 minus 20 makes minus 4. And then down here in the denominator, I don't need to do anything with that. I'm just going to leave it 5 parentheses k minus 2. All right, so now we're going to check right here. Can I simplify or factor that numerator? Can I reduce this or simplify, break this down anyway? This is a perfect square, k squared minus 4. So that's going to break down to k plus 2 and k minus 2. And the way I got that was by taking the square root of 4 and the square root of k squared. This gives me k, this gives me 2. K plus 2, k minus 2. It's always plus and minus. And then the denominator stays the same. And I'm just going to tell you, sometimes things don't reduce, sometimes things don't cancel out, and you would just leave it like this, okay? Or you could even leave it like this if nothing crossed out. But here you see k minus 2, k minus 2, so that part's going to go away, and we're going to be left with k plus 2 over 5. And typically we don't write the parentheses in our final answer if it's all by itself. If there was something else with it, we would need to leave the parentheses there. All right, a couple more just because this is brand new. It's got a couple extra steps. All right, so this one is going to say 7 over y plus 8 plus 35 over y squared plus 11y plus 24. Okay. Problem. If you do 7 plus 35, you will get 42. If you add this together, you'll get whatever, and it will be totally wrong because that is not the way that we add fractions. Okay? In order to add fractions, you cannot add these numerators until these denominators are exactly the same thing. So we have to make sure we get that common denominator first before we move on. Okay? All right, so y plus 8, that doesn't simplify or anything, so I'm just going to leave that one as it is. And then over here, the 35 is going to stay as it is because I can't reduce that at all. And then down here, can I break down this y squared plus 11y plus 24? I can. I'm going to break it into, let's see, factors of 24 that make 11. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of those make 11? 3 and 8, and these are all plus, so it's going to be y plus 3 and y plus 8. Oops, I kind of got up in my space there. Oh well. Okay, pretend this isn't here. Not there. Okay, so we're looking for our common denominator now between y plus 8 and y plus 3 times y plus 8. Okay, notice that they both have a y plus 8, so we will probably need that in our answer. What else do you see? This one has a y plus 3, so I'm going to need that to go over into my other fraction so that they will both have a y plus 8 and a y plus 3. Okay, so again, we look now at this first fraction, and we just said we're going to multiply this by y plus 3 so that we'll have y plus 3 and y plus 8 in the denominator, and we'll multiply the numerator by y plus 3. All right, here's how we do this. It's a distributive property. 7 times y, 7 times 3. 7 times y and 7 times 3, 21. Both of them. Okay, then I look at this one. What did I need to multiply this by to get this? Say it again. What do I need to multiply this by to get this? Nothing. Absolutely nothing. So the 35 is just going to go there. It is a plus 35, so we're going to bring that sign across as well. Okay, so now we're going to combine across the top. I've got a 7y, and let's see, 21 plus 35 makes 56, and then I still have y plus 8 and y plus 3. Let's see, can I break this numerator down at all? So maybe I can cancel one of those out. What do we know about 7 and 56? 7 to 7 go into 56? It sure does. How many times? 8 times. So 7 times parenthesis y plus 8, bringing out the 7. And then I have y plus 8 and y plus 3 on the denominator. And And these are going to go away and leave us with 7 over y plus 3. Boom. It's cool, y'all. This brings out the math geek in me. I really love it. Okay, we are going to do one more for today. Okay, and then I'm probably going to give us another day on this where I do a couple more of the like more lengthy problems. These aren't really, well, not really lengthy, but whatever. Just a couple more. We'll do another day of practice of this as well. Okay, so let's try one more for today. X squared minus 5 over x squared plus 5x plus 6 plus 1 over x plus 2. All right, so common denominator. I do not want to try to multiply all of this by all of this. That's crazy. Okay, so what I'm going to do first is I'm going to factor this, if I can. Factor. All right, so the top is going to stay the same. The numerator stays alone. Okay, so here I want to factor into 2 parentheses. I need 2 numbers that multiply to make 6. But add to make 5. Okay, and this right here tells me that my signs are both going to be the same. So I'm either going to have positive, positive, or negative, negative. But since this is plus in here, they're both going to be positive. So I'm really only looking to add my numbers, not subtract. Because I could subtract these to get 5, but I don't want to do that. I just want to add. So x plus 2 and x plus 3. Okay, and I'll give you a little hint. If you already have one factor over here, that is probably, at least for now, that's probably going to be one of your factors as well. Okay, so that kind of gives you a hint of what it should be. This one's going to stay the same because I can't reduce that or anything. So now we're going to look at our denominators. What terms do these have in common? I see that they both have an x plus 2. This one has an x plus 3, so I'm going to need that as a factor as well. So, on this first fraction, do I need to multiply this by anything to make this? No. So this top numerator is going to stay the same, x squared minus 5. And then over here on this side, we already have an x plus 2, so we're going to multiply this by x plus 3. So that our denominator now has an x plus 2 term and an x plus 3 term. And we're going to distribute. Now remember, this is a positive 1. This is a positive 1, and we're going to distribute it. So positive 1 times x makes positive 1x. And positive 1 times 3 makes positive 3. If this was a minus sign, you got to be really, really, really careful. Okay, I don't have any of those yet today. I'll have some for you next time. Okay, all right, so let's finish this out. We're going to combine like terms up here in the numerator. We have 1x squared, so that's going to be by itself. I have 1x term, so that's going to be by itself, that positive x. And then I have this minus 5 and a plus 3. Minus 5 plus 3 makes negative 2. And the denominator is going to stay. So we're going to look at this numerator and see if we can break that down. Can we break down an x squared plus x minus 2? I believe so. So I need 2 numbers that multiply to make 2 and add to make a positive 1. So if I want to add these to make 1, is it going to be 2 positive 2 minus 1 or negative 2 plus 1? Which one makes positive 1? Not that one. So x plus 2 and x minus 1. And again, this is kind of a hint. I'm not saying that it works every time, but I would start with that if that was already a factor. Okay. Oops. So do you see something that cancels now? So we're left with x minus 1 over x plus 3. Okay. Yay! Love this. Okay, y'all, I'm going to give you a couple problems to practice with. I don't know exactly how many it is, 4 or 5. Okay, if you have questions, please come and see me during the Zoom meeting at 9 a.m. or send me a text and ask me for help. Okay, love you, bye.